All right, thank you for stopping by. This is the first session for week 7. Oh, sorry, week 3. I just skipped over 4 weeks. Um, okay, so tonight we're going to be doing module 3, and I'm going to go over some of the concepts, and we'll do a few problems, and then I'm hoping that we can do at least half of the problems tonight. This is the first session, and then the second session will be tomorrow at 9 p.m. Eastern Time. Thank you for, again, for allowing me to reschedule this week. It's been a bit hectic, um, but from next week, I think we should be back to the normal schedule on the Tuesday and Thursday. Okay. Yes, Donna, you have excellent memory. So, um, I'll just briefly talk about it tonight, and then we can discuss it in a little more detail, maybe like during week 6. So, Donna, I would like you to still remember this for week 6, but during week 8, um, we're going to have 3 sessions instead of the regular 2. So there will be hopefully maybe 2 or 1 session. So there will be either 1 or 2 sessions for week 8 homework, and then there will be a special webinar session for the final exam. So for the final exam, basically, we're going to go over a few, concepts and problems, that will help you prepare for the final exam. Okay. Yes, Brian, I can, but then I would have to give you a grade maybe that you are not gonna like. Can you also tell me where I can find previous recorded sessions? Yes, I can show you that tonight. So, no need to panic, Tara. Once I go, that webinar session, the final exam webinar session is actually quite popular. Students like actually really like it. They think that it prepares them very well for the final exam. So, um, you know, I'm sure you'll do just fine once we go through everything there. So don't worry about it. All right, so let me share my screen. If you can tell me if you can see my screen. Okay. Yeah, Brian. I'm hoping we can get to the T distribution problem. If not tonight, definitely tomorrow. Okay. So last week we were studying, the normal distribution, right? And we had discussed, so before I get started, actually, let me just show you how to get to the recordings. The easiest way to get to the recordings is to go to Professor David's website, okay? And that website is this address right here. And if you click this, you'll be taken to the website where under 16EW1, which is the term that we're in, you'll see the recordings being posted here. Okay, so tonight's recording will be posted right in front of week 3 here. Okay, this is the easiest way to get to it. The other way is to go into your course in Blackboard. So go into your course shell and then look for webinar information tab on the left. And then once you click on it, you'll see that if you scroll down, you will be able to see the calendar. The webinar, it's a course calendar where the recordings are posted under the day they're held. Okay. All right. So let's get started. So tonight I want to talk about the level of confidence. Okay. So what is the level of confidence? So for example, a problem like this where it's saying compute the critical value that corresponds to 89% level of confidence. Okay, so it's very simple. Okay, let me check this. All right, so level of confidence, the concept is very simple. Okay, so imagine you have a normal distribution and say that yes, you can do it in StatCrunch, and we're going to do that. So I'll show you how to do this in StatCrunch. So, but I would like to talk a little bit about the concept so that you understand, what we're going to be doing there. Okay, so a problem, for example, something like this where you have a normal distribution curve, and what I want to add, I'm going to give you two scenarios, and then you'll tell me which one you like better. Okay, so in scenario number one, okay, first of all, the problem statement is that you have to maybe estimate population proportion. Okay, so you have to estimate some proportion, p hat. Okay, you have to estimate a proportion. Tell me if you like scenario one or scenario two. The first scenario is you take the data, okay, and it's the normal distribution, and you estimate p hat and say, the estimate is going to be in the middle. So this is the estimate that you're trying to predict. So here you're just predicting p hat. So find p hat. Okay, that's what I'm going to say. I'm going to say find p hat. All right. This is the first scenario. The second scenario is instead of finding p hat, I will tell you find a lower and an upper limit, maybe like this far. Okay, a lower and an upper limit where you think that p hat would fall within those limits. Okay, so I'm going to call this find limits. Okay, so let me just explain this quickly again. In the first scenario, you were trying to find the p hat, okay, the exact value of the p hat, the exact estimate of p hat. In the second scenario, you're not doing that. All you're doing is finding some low value and some upper value, and then saying that, okay, now the p hat would fall within this, okay? And you'll give me some probability that you think that it's 80%, certain that p hat is going to fall within these limits, or maybe like 90% probability that it will fall within this limit. So let me ask you a question. Which scenario would you choose? Which one do you think makes more sense to you? Number one or number two? Yeah, right. Absolutely. Number two makes sense, right? Number one, when you have to estimate p hat, the exact estimate, right, of the population, it's going to be hard. It's going to be hard for you to, you know, have a population. So this is say a population, and you take a sample. So this thing has a p hat, which is p, whatever proportion. So maybe I'll use an example. Say the actual population proportion is 75%, but you don't know this. So you take a sample and you estimate the p hat, this value, you try to estimate it, and say you fall, obviously, it's very unlikely that you're going to get exactly 75%. You may fall short sometimes. Maybe you might find that it's 68%, or maybe sometimes you'll try to calculate it and you'll get something like 77%. But it'll be very unlikely that you'll find the exact value, right? But it's much easier for you to sort of find a lower and an upper limit. Say, for this case, maybe you take the sample and you find that the lower limit maybe is 65% and the upper limit is 85%. And you say that you're certain, whatever, with 90% probability that your estimate falls, the true estimate, which is 75%, falls within this range. And you all agree with me that this makes a little bit more sense to use, right, in practical life than this. And that's absolutely correct. That is exactly what we're trying to do tonight, okay? So in the first question, the question says, compute the critical value that corresponds to 89% level of confidence. So what that means is the first thing to note is that you have to draw it out and then it said 89% level of confidence. And what that means is you put a lower limit, put an upper limit, and then the area between them, the area under the curve between those limits is 89% or 0.89. Okay? So essentially, whatever level of confidence, and it is literally what it's saying here, okay? How confident are you? Okay, in this case, you're 89% confident. 89%, this is the 89% level of confidence, right? Where the middle area is 89%. And the question is saying, find this value, the lower limit, and find this value, the upper limit. You need to find these values. This is plus z, and this is minus z. We're using z because this is the, what is z again? Can you recall what z is? Nope. Z, remember Z from last week? Critical value Z. So Z is standard normal. Remember that? Standard normal distribution. And in standard normal distribution, what is the mean and what is the standard deviation? Can you recall that? Standard normal distribution, the mean is 0 and the standard deviation is 1. Very good. So so what we need to find are these small z, okay, plus z and minus z. We need to find these values between which you have 89% area or 0.89. Okay. Now, a lot of times you're going to see they're going to refer to this as z alpha over 2. What alpha means, alpha is the sum of this and this area. Okay. Whatever is left. So can you tell me what alpha is here? 0.11. Yeah. Very good. 0.11 because it's 1 minus 0.89. Now, another thing to remember here is, okay, first of all, did you follow this? Did you follow how I got all these numbers? Question said 89%. I put 80.89 in the middle. Whatever is left is alpha. That's 0.11. Okay. All right, good. Now, notice it says Z alpha over 2. Z alpha over 2. So alpha over 2 is going to be, what is it going to be? Yeah, so 0.055, right? So 0.11 divided by 2 is 0.055, okay? And what that means, alpha over 2, what that means is that it's one area, either this or that, okay? So it's one of those areas, right? Together, it's 0.11, so obviously each one is 0.055 each, okay? So this area is 0.055. And when they say find z alpha over 2, what they mean is find the critical value z. This is called the critical value, okay? Both of these are critical value. This is the lower critical value. This is the upper critical value. So you have to find the critical value z alpha over 2, meaning what is the critical value when your area is alpha over 2. In this case, is 0.055. So you need to find this value. Okay. Now remember that this will always be reported as a positive value. You will never enter the negative, the lower limit. Okay. That's how these questions are asked. The question will always take a positive value. Okay. And then it will assume that you know that your lower limit is on the other side. So say if you get the critical value as plus 1, 1.5 say, then your lower critical value is minus 1.5. It automatically knows that. But in the problem, you just have to enter this. So now let's do this problem. Okay. So The easiest way to do this is StatCrunch. Let me show you how to do that. Okay, so we're going to use stat calculator and our friend from last week, normal calculator. Okay. Now that this is here, now instead of going, I wonder if we can solve this here. Let's see. Let me first test this. Wow, it does. Okay, so the way to solve this problem is to click on between, okay, because that's what we're interested in. The area between, right? The area between this, these two limits, or in the middle of the normal distribution curve, is 0.89. So what I'm going to do is use the between option and enter the area in this box as 0.89. All right, and then I'll hit compute. And look what it gives you. It tells you that the upper limit, right? This is the upper limit, is 1.5982, which is this limit right here. So this area, this value here, you can see is between 1 and 2, and this value happens to be 1.5982. And then the other side is because it's a symmetric curve, right? It's just the negative of that value, so it's just negative 1.5982. Okay, so the answer to this is 1.5982. So this will be this 1.5982, and this here is minus 1.5982. And when you report it, you're going to report only the positive value in the problem. So 1.5982, but you need to round it to 2 decimal places. So 1.598 rounds to 1.60. That's why the answer is 1.60. Does that make sense? So what did we do today? We talked about level of confidence. That's how confident you are that your estimate is between a lower and an upper limit. Okay. Alpha is 1 minus whatever your level of confidence is. Alpha over 2 is just divided by 2. Okay. And then all you have to do is use the StatCrunch calculator, normal calculator, to find your critical value Z. Okay. So somebody had asked to show this again. Well, what I did was I went to stat, calculator, normal, and then I'm going to go to between option. And all I have to do is type the level of confidence here. So 0.89 is what we're looking for, the area in the middle. If I hit compute, just make sure that the area in the middle is highlighted. This is your 89% level of confidence. The upper limit is 1.5982. The lower limit is minus 1.5982. Okay. I see that some of the students are answering questions from Rob. So thank you for that. So what do you think? This is a simple problem now, right? Now you should all know when you see level of confidence, it should make sense. What it is just the area in the middle. And then alpha, is just 1 minus level of confidence. And then Z alpha over 2 is just the critical value. Okay. All right. Go to question number 2. Okay. Now this is a little bit different, but it's not entirely that different. Determine the point estimate of the population proportion, the margin of error. Okay, so the definition of critical value I just explained is just the level of confidence, which is the area in the middle. The upper limit is where that area ends, and the lower critical limit is where that area begins. That is all it is. Okay. Determine the point estimate of population proportion, the margin of error for the following confidence interval, and the number of individuals in the sample, blah, blah, blah. All right, so there are a lot of things in this problem. So let me now, again, talk a little bit about what we had discussed just a little bit earlier. So imagine you have a population, okay? You have a population, and just for the sake of this example, we're going to say that the true proportion for the population is 60%, okay? You take a sample and say you don't know this is 60%. You take out a sample and then you estimate a p, okay? You estimate a p in order to, estimate this population proportion. You calculate a p using the sample and say that that comes out to be, you're probably going to be off a little bit, so 57%, say. All right, this is the first scenario. The second scenario, again, is instead now you use this sample to find a lower value and an upper value, right? So say your lower value is 55%, the upper is 65%, okay? And you all agreed that this was a better choice. You all agreed with that. Well, it just so happens that there's a name for this, and the name is, it's a confidence interval, okay? So what is a confidence interval? Well, it's simple. This is an interval, right? We know it's an interval because it has a lower and an upper value, and all values in between are included. So this is an interval, right? This is also a confidence, we also are using a level of confidence here because remember, just a while back, just a minute ago, we talked about the level of confidence. How confident are you in your in that lower and an upper limit, right? This is why it's called a confidence interval, because you're using the confidence to determine how confident are you, what is the probability, right, of you being that confident. And it's an interval because it is an interval. It has a lower and upper limit and everything is included in the middle. So it's a confidence interval, okay? The point estimate is just an estimate, okay? It's just an estimate. Just like we took the sample and we calculated the sample proportion, this is a point estimate, okay? It's just an estimate. It's just an estimate trying to estimate the population proportion that is unknown. So let's start with p hat. P hat is a point estimate, okay? So it can be whatever. Say in this problem, it was, we can say that it was 60%. Or in this problem, actually, it was 57% is what we used. Now, how do we go from this 57% to a confidence interval? How do we find that? Well, what we can do is use the point estimate p hat, for example, and then add and subtract some margin of error. Okay, so what is a margin of error? It is a margin in which you are allowed to sort of make an error. Okay, so essentially what this means is, for example, in this case, 55% to 65%. If your true estimate, instead of using 57, I'm just going to use 60. If your point estimate was 60%, your margin of error, what is your margin of error? Now, be careful. I'm going to say plus and minus some margin of error. So plus minus margin of error and minus margin of error. So what is your margin of error in this example? It's 5% because you're saying I'm 60% and I'm plus and minus 5%. What that means is, what is the lowest value that you can have? Well, it's 60 minus 5, 55%. What is the largest value that you can have? It is 60% plus 5% or 65%, right? So the margin of error is how far off are you from your point estimate, the maximum allowed error from the point estimate, okay? So let me ask you a question. If I have, I'm going to use 60% p hat again, right? So say that I calculate my margin of error and it comes out to be 2%. And in the second example, my margin of error is say 5%. Okay. So in the first example, my margin of error is 2%. So can you tell me what is the lowest and um, the smallest and the largest value? 58 and 62. Yes. So 58% and 62%. Very good. And what is the smallest and the largest value here? 55 and 65%. Now let me ask you a question here. You have these two confidence intervals. Which confidence interval is more precise? Which confidence interval is giving you a more precise answer? Yep, the first one. Very, very good. Okay, now I was wondering if I would have to explain this, but apparently you all are following this. Very good. This is more precise because you have less margin of error. Your confidence interval is narrower, meaning you are really sure that is contained within a narrower margin. So you're more confident in this case that that you're um, well, I shouldn't say that. What's happening here is that you have a more precise confidence interval, meaning you are able to predict with a little bit more certainty in a narrower margin. Okay. In this case, your margin of error is large, is 5%, and therefore the confidence interval is wider. Okay. So you have to sort of use a wider range, to be able to, to be however much confident you are. But this is the essential thing to remember here is that p hat plus and minus some margin of error is a confidence interval. Okay. And how do you write this? The lower limit is p hat minus margin of error, and the upper limit is p hat plus the margin of error. Okay. Now I'm going to keep this here and I'm going to do this problem. So what we have is we have a lower bound given to us and an upper bound given to us. So let me just write this down. So the lower bound, I'm just gonna write it in the form of a confidence interval. The lower bound is 0.288 or 28.8%. The upper bound is 0.772. Okay, so this is the lower limit, this is the upper limit. So tell me, what is the point estimate in this case? P hat, point estimate. What is it? How do we find it? Aha, Andrea has it absolutely correct. Vince, that equation is a little bit off. You're very close, but a little bit off. I think it's off. So the way I do this is this way. To find p hat, what you would do is this. Take the lower limit, add it to the upper limit, and divide the whole thing by 2. Okay? Does that make sense? So I wonder if Jordan and everyone else who wrote that equation, if that's what you meant. I see. So I thought you meant this. Okay. So essentially you have to use the parentheses to make sure that you're dividing you're dividing the whole thing by 2. Okay. But if that's what you meant, you're absolutely correct. This is the best way to solve this. You take the lower limit, take the upper limit, add them together, and then divide it by 2, and that will give you exactly the midpoint. The midpoint of those two limits is your point estimate, p hat. So in this case, what is it going to be? Let's find out. All right, so I'm gonna use the calculator. I think the calculator is the best to use here. So it's 0.288 plus 0.772, and you divide it by 2, and everyone says it's 0.53, and that is the correct answer. Any questions here so far? Okay, good. Now the question says, so by the way, let me just show you the answer. See, the answer is 0.53. Okay, now the question says, what is the margin of error? So what is the margin of error? How do we find this? How do we find the margin of error? Any ideas? Jordan, no, because that would be the point estimate, right? So that is the point estimate, which we just calculated. Aha, look at Andrea's answer is really good. Brian's good. Yep, that's right. So what you do, so let's just use one of these two equations, okay? And let's just always use this one. All right, you can use either one, but I'm going to just use this one. So let's write it down. P hat plus margin of error. This is the upper limit. And the question gave us the upper limit. The upper limit was 0.772. So let me just write UL, upper limit. And now I'm going to put the values in it. So what is P hat? We just calculated P hat. P hat is 0.53 plus margin of error, which we need to find, and it equals the upper limit. The upper limit the question gave us was 0.772. Okay, so margin of error is simply 0.772 minus 0.53. Basically the upper limit minus the point estimate. So what is that? Let's do it. 0.242. Okay, so 0.242 is your margin of error. Okay, and I can test this. Now let's do a quick test. This is the lower limit, this is the upper limit. 0.53 is your point estimate in the middle. It's right in the middle here. So I just take the upper limit, 0.772. I subtract the point estimate, 0.53, and I get 0.242, which is your margin of error. So I like to draw a diagram on this actually. So what I do is, I always like to do this because it helps me visualize it. Here's the diagram I draw. Straight line with a starting point and an ending point and a center point. The starting point is 0.288. That's the lower limit. This is the upper limit, 0.772. The middle is 0.53, the point estimate that we found. Okay. And what is the margin of error? This is the margin of error. What is the difference here? 0.242. If you can draw this anytime you are asked this question, you'll be always correct. You'll always get to the correct answer if you can just sort of visualize the problem. Okay, any questions on this so far? Margin of error and point estimate. Any questions? Everyone's quiet. Can I get a few more yeses or no's, I guess? If okay, good, good, good. Everyone's good? Great. Jordan, you were correct. I think you just wait a minute. You're saying, let me see. You said 0.288. So basically you said 772 divided by 2 plus 0.288. Yeah, so I think no, you're correct. That was correct. I thought you had typed this before. I thought that's what you had typed before. So, but it should be the whole thing divided by 2. Yeah, so Alfred, that's a good question. So as we, some of these notations can get really confusing, but whenever you have a population, you have P, proportion, okay? We use the letter P to represent population proportion. So this is the population. Whenever you use a sample to estimate the population proportion, we use P hat. Hat is to say that we're trying to estimate the population proportion, okay? Because the population proportion is usually unknown to us. Okay, so that's why we use P hat here, because we're relying on the sample. So the takeaway from here is, remember this, try to visualize, okay, this diagram here, always draw it out, and remember this formula here, and then you'll be all right. The last part of the problem says the number of individuals in the sample with specified characteristic. So my N is 1500, okay? Total sample size is 1500. We said that the point estimate of population proportion is 53% or 0.53. So how many individuals in the sample have that specified characteristic? And just like Brian said, it's simply just the point estimate 53% times N, 1500. That is all it is, okay? So it's 0.53 times 1500. And that should give you 795, which is this answer. Any questions? Great, everyone's following this. That's excellent. Awesome. Okay, well, I spent quite a bit of time on the first two problems, but I think this will get us going now. Okay, so now we actually have to construct the confidence interval. Okay, we are not given margin of error, and we are not given, we're actually not given the p hat, okay, the estimate of the proportion. So all we're given is x, n, and the confidence, the level of confidence, okay? So how do we do that? Well, I always like to visualize the problem. So what I'm going to do is I like to draw a diagram, something like this, okay? This here represents the, again, the normal distribution curve. And underneath this diagram, I'm going to draw a line also. Okay, the same line I drew before. It has a sorry. It's going to start, maybe, let's say it starts, just for the sake of it, maybe let me use a red color. Say the lower limit is here and the upper limit is here, so that the line will be this way, right? And the center is here. So obviously the center will go through, the center will be here. Okay. I would like you to draw this because you'll see that it's going to help you visualize the problem. So what do we have? We have x is 860. X is the characteristic that we're studying. There are 860 items or individuals that have that characteristic. and my total sample size is 1200. So what is my p hat? What is my p hat for this problem? 860 and 1200. So what is the p hat? Yeah, it's just x over n. Very good. It's 860 out of 1200. And so what is that? So let's first calculate that. It's 0.7167. Okay, so I'll use a few more decimal points. This is my p hat. Okay, 0.72, you can use 0.72. That's also correct. So this is my p hat. All right, so this is the center, 0.7166. So this is 0.71. Should have, let me just, should I expand this, or yeah, I think you'll all follow this. Okay, this is my center value. Now, the trick in this problem is to find the lower and the upper limit. All right, so please follow this. This is very important. My level of confidence is 99%. You have to be 99% certain of your lower and the upper limit. Okay, so how do we do this? Well, just so happens that there is a formula I can use. First, I'll show you the formula, and then I will show you how to do this in StatCrunch. Here's the formula. This guy, p hat, is here. This value is going to be z. Oops, hold on. Not that value, but the margin of error, which is this guy. Okay, this is the margin of error. We all agreed with that, right? The margin of error is going to be this formula. It is very simple, and I'll step through it, and then you'll see that it's not that bad. Okay, this is the margin of error. Margin of error is simply just a z alpha over 2, sorry. Z for alpha over 2, okay, so this is the critical value z, the critical value, times the square root of p hat times 1 minus p hat divided by n. So, for example, in this case, in this example, I need to find the z first, but let me find that later. It's square root p hat. Did it say 95%? No, for me it's 99%. For everyone is going to be different. Okay, so for my problem it is 99%. Okay. Okay. Let me plug the values in. Okay, p hat is 0.71667 times 1 minus p hat divided by n, which is 1200. Okay, so I have my p hat, I have 1 minus p hat, I have my n, I have everything here. I don't have z, so I need to find z. What is z? Z is 99, the critical value for 99% level of confidence. We did this problem. This is problem number 1. How do we find this? Well, let me just put 99 here. Okay, I'm in the between option. Let's just put 99. What do we get? 2.5758. That is my critical value, 2.5758. So 2.5758. This is my margin of error. This whole thing is my margin of error. And now here's the cool thing. The confidence interval we defined as p hat plus or minus margin of error. So do you all agree with me that once I find this value, the margin of error, whatever value this comes out to be, I can find my lower and the upper limit. Do you all agree? Because I have my p hat and I will have my margin of error. My lower limit will be p hat minus margin of error. The upper limit will be p hat plus margin of error. Do you all agree? The 2.5758 came from calculating the critical value for 99%, right? So I put 99 here, which is the area under the curve, right, in the center, and it will give me the upper limit, which is 2.5758 here, and the lower limit, which is minus 2.5758, right? So I'm just going to use a plus value to put here as z alpha over 2. So that's how it came here. And now once I have all of this, it's just plain arithmetic, right? It's just find the margin of error. And once you have found it, you got both of these. You got margin of error, you got p hat. So you can find the lower and the upper limit, and that's the answer to this question. Okay, you'll see that in this case, it wants you to find the lower limit, the lower bound, or the upper limit, the upper bound of the confidence interval. That's how you find it. But let me show you how to do this in StatCrunch. I wanted to first confirm that you can use this formula to do this problem. And now you know you can. You can find the p hat, you can find the margin of error, and then you have your answers. But StatCrunch will do the same thing for you. So let me show you how to do that. For that, what you have to do is you have to go to Stat. This is the first time we're using it, so please be careful here. We're going to use proportion stats. We're going to use one sample, and we're going to use summarized data. Okay, so I'm going to use with summary. Okay, the rest is very simple. Number of successes, which is, how many items or individuals you have with the characteristic. I have 860 in this problem out of 1200. And instead of the hypothesis test, let me choose this confidence interval. And notice it's calculating right now 95% confidence interval. For my problem, I need to find 99%. So I'm going to change this to 0.99. Okay. So if in your problem, if in your question, if you have, say, if you are asked to do 95% confidence interval, then you're going to just put in 0.95. Okay. 85% will be 0.85. For me, it's 99. So I'm going to use 0.99. And I hit compute. And look at this. Isn't it amazing that StatCrunch clearly gives you the lower limit and it gives you the upper limit? Isn't that nice? It basically did what I just showed you. It basically did what I just showed you in this whole thing. It just did that. Isn't that nice? And I'd like you to sort of tell me if you appreciated this. Okay, let me show you one more time. So I went into, well, let me start from the scratch. So I went to stat, proportion stats. Okay, proportion stats meaning, we're using proportions, one sample, and I want to use with summary. I had 860 number of successes, 1200 observations, confidence interval. I need to find 99 for myself. So I need to choose confidence interval option, put 0.99 and just hit compute, and I get my lower and the upper limit. And that's how you do these problems. Whenever you have to find the confidence interval for proportions, you're going to use stat proportion stats option. Okay. So next week we're going to do 2 sample. This week we're just going to do 1 sample. So 1 sample with summary. Pretty much that's what you're going to be doing. Okay. So once you have your answers, you'll just put them here. The upper bound. By the way, sometimes they call it the bound, the upper bound or the lower bound. Same thing as upper limit, lower limit. The upper bound is 0.75, the lower bound is 0.683. And you'll see that right in the middle of these two is your point estimate. Okay. Jordan, it shouldn't be. Should not be. Shouldn't be off. Maybe we can talk about this after the session, but it should not be off. Okay, can I move to the next problem? Are you all okay with this problem now? Finding the confidence interval? Okay, great. Okay, so now a poll of 1567 adults in a certain country found that 55% identified as followers of some religion. Okay, so what is your p hat in this statement? What is your p hat? In the first statement, what is the p hat? Is 55%. Okay, that's your p hat. 1567 is your n. Okay, your n total sample size is 1567. P hat is 55%. The margin of error was 5 percentage points with 95% confidence. Okay, so it's a lot of words here. So let me draw it out. Whenever you get confused in statistic, at least for me, what works is drawing it out. So if I draw it out, what I'm going to do is I'm going to draw a confidence interval again, lower limit, upper limit, and a point estimate in the center. The point estimate, it says, is 55%. It says that my margin of error is 5 percentage points. So my upper limit is going to be what? 60. Good. The lower is going to be 50. And it also tells me that I am 95% confident. So my level of confidence is 95%. Okay. So all you have to do in this problem, you don't have to do any calculation. There's also what we call an interpretation of the results. Okay. So whenever you create a confidence interval, you have to explain what that confidence interval is. What does it mean to have that confidence interval? So we just found the confidence interval. It is 50% lower limit, 60% upper limit. And all of these statements, the first three are wrong, except for the last one. And let's just go through the correct one and then we'll go through the wrong ones. We are 95% confidence, or we can say that there is 95% confidence that the proportion of adults in a certain country who identify themselves as followers of some religion is between 50 and 60%. Remember when we started this session tonight, you told me that you liked giving a lower and an upper limit instead of just saying that 55% is the actual proportion, right? You told me that you like the approach where we have a lower and the upper limit. Well, part D does exactly that. Let's look at part C. Part C says there's 95% confidence that 55% of adults in a certain country identify themselves as followers of some religion. What is the problem here? The problem here is that this is the approach that you did not like. Remember? The approach where you are giving only one statistic, which is the point estimate. You're saying that you have found the point estimate for population proportion using just a small sample. Well, it may or may not be correct. And most likely it is probably off. So this is not a good interpretation at all. In 95% of the samples of adults, the proportion who identify is between 50 and 60%. The problem with this statement is right here. In 95% of the samples. Here, we're not using 95% as sort of like a confidence. You're using 95% as a proportion itself, right? You're saying however many samples you have, 95% of them, have proportions between 50 and 60. No, that's not correct. 95% is a confidence level. How confident are you? It is not a proportion itself. So B is wrong. And then the first one, there is between 90% and 100% confidence. That's completely wrong right there because we never ever use margin of error on the level of confidence. Margin of error is always used on the point estimate. In this case, it's used on the 55%. So we do 55% plus or minus 5%. We don't do 95% plus or minus 5%. We never do that. We never use the confidence level and then, subtract or add the margin of error with it. Okay? So A is wrong. Only this is correct. There is 95% confidence, that's right, that the proportion of adults, blah, 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 is between 50% and 60%. Okay? Does that make sense? Awesome. Okay, make sure to remember this because sometimes you're going to get questions like this and it's easy to get the interpretation wrong. All right, now you're going to help me do this problem. In a trial of 260 patients who received this drug, 39 reported headaches as a side effect. So what proportion, obtain a point estimate for population proportion of patients who received the drug and reported headache. So how do we find yeah, that's it. It's that simple. It's just 39 divided by 260. Okay, so if I use the calculator, it's 39 divided by 260 or 15%, 0.15. Now, I should have pointed this out before, but if you want to use this data to calculate a confidence interval, there's one requirement that you have to test. Okay, and it's very easy. It's almost always going to be met, by the way, but you should check it. And it is simply that your n times p hat times 1 minus p hat should be greater than 10. Okay. Wonder if it's greater or greater and equal. Let me think about this. I think this should be greater or equal. So it can be 10 and then you're also okay. All right. So let's test for this problem. Okay, we have a new problem. So I'm gonna open a new sheet. Just use black color here. So the problem says, do we meet the requirements to make a confidence interval? And this is the requirement we need to test. So my n is 260. My p hat you all said was 39 divided by 260, which was 15% or 0.15. And then I have 1 minus p hat, which is 1 minus 0.15, which is 0.85. And the question is this greater than or equal to 10? So I need to calculate this whole piece here. Let's find it. What do we have? 260 times 0.15 times 0.85. I get 33.15. The question is 33.15 greater than or equal to 10? Yes. So I can go ahead and estimate a confidence interval. Okay. So let's construct the confidence interval now. So I'm going to go to StatCrunch and you're going to help me do this. So let me just tell you the parameters of the problem. I need to find 99% confidence interval where my x is 39 and my n is 260. Okay, so you're going to help me do this. So how do we do this? So if you can just walk me through it. Stat. Proportion stats, very good. One sample with summary. Excellent. Okay, what am I going to enter for number of successes? 39, very good. How about number of observations? 260, excellent. What else do I have to do? Yep, choose confidence, choose this, and type 99. Very, very good. And that's all. And then I just hit compute. And there it is. 0.093 is the lower limit. 0.207 is the upper limit. So here it is, 0.093, 0.207. And now they want you to interpret the confidence interval. Very simple. We are 99% confident that this interval contains the true value of P. So remember, in the previous problem, we sort of used a similar interpretation. But what we said was we're 99% confident that the true value of P is between this or contained within this interval is between 0.093 and 0.207. Okay. Any question here so far? I think this was fairly straightforward. Okay, excellent. Now this problem is a slightly different. So let me go through this first. Yeah, just need practice. That's right. So a researcher wishes to estimate. Okay, David, we're going to be here for just maybe another 15-20 minutes, and then we'll be going as well. And then you can always see the webinar recording. All right. A researcher wishes to estimate the proportion of adults who have high-speed internet. What sample size should be obtained if she wishes the estimate to be within 0.02 and with 90% confident? Okay, so let's do this problem. Yes, the recordings will always be available. Okay, so now what we're doing, so I want you to first remember this formula. So remember we had the confidence interval for proportions was p hat plus or minus margin of error, okay? And we represented that with this diagram. This is the lower limit, this is the upper limit, and then you have p hat in the middle, okay? So you all agree with this, and we said for proportions, the margin of error is given as z. I wrote this formula, so you can go back and check. So we said that this is the formula for margin of error, right? Now it's very simple. Now we have to find what sample size. So first of all, the problem has given us some things, some of the things here. So let's see what it has given us. it has given us, it says, let me show you. It says what sample size should be obtained if she wishes the estimate to be within 0.02 with 90% confidence. Okay, so first of all, the level of confidence is 90%. Okay, this is given to us. So let's find Z. What is the Z for 90% confidence? I'll go to stat, calculator, normal. I'll go to between. I'll type 0.90, and that gives me my critical Z value, which Sal wrote as Z alpha over 2. That is 1.6449. Okay, so 1.6449 is my Z. And we have just found this guy. Okay, what else has this problem given to us? It also says if she wishes the estimate, so there's the researcher is trying to calculate or estimate, or get an estimate, but the estimate should be within 0.02, so which is 2%. So that is going to be my margin of error. My margin of error must be within 0.02, which means it's 2% or 0.02. So that is my margin of error. So this is given to us. Okay. We need to find the sample size. Okay, that is the question. We need to find the sample size. So this is not given to us, but we have to find this. This guy we have to find. So we have everything in this equation except p hat. We don't know what p hat we should use. Well, the problem gives you a hint. It says if she uses a previous estimate of 0.52, this is the point estimate to use, 0.52. So we now have p hat, and we also now have 1 minus p hat. So in other words, if I just rearrange this equation, okay, and solve for n, I would get this. Now I'm not gonna do the sort of like the algebra, take too much time, but I can tell you that n is going to be equal to p hat 1 minus p hat z over margin of error square. Essentially what I did was I took this equation and I solved for n. Okay, I took n on one side and everything else on one side, and this is what you should get. Okay. Now, do you all agree that we can do this? We have p hat is given as 0.52 in this problem. We also have 1 minus p hat. We have z, we just found it. We have margin of error, we found it here, right? The problem gave it to us. So everything is here. So do you all agree we can find n? Right? So I can just solve this equation. I can just pretty much say my p hat is 0.52, 1 minus 0.52, 1.6449, and margin of error is 0.02. I can solve this and I can find my n. But the nice thing is you can do so in StatCrunch. So let me show you how to do this in StatCrunch. You're going to go to stat. You're going to go to proportion stats. Same thing, okay? Because we're still using proportions. You're going to go to one sample. Instead of going to width summary that we used before, you're going to actually access this width and sample size option, okay? Width/sample size option. Here, you're going to type what is given to you. I want 90% confidence level. My target proportion is given as 0.52. That's my target proportion. My width, okay, now this is a little tricky. This here says width. It doesn't say margin of error. And what it's saying is really this guy. It's asking you to enter the whole width of the confidence interval, okay? Not just the margin of error. Margin of error is this guy. So let me ask you, what is this equal to? The whole width, what is that equal to in terms of margin of errors? Yeah, it's just twice the margin of error, right? So if my margin of error is 2% here, what is the total width? Is 4%. So 4%, or I'm going to enter 0.04. Okay, and that's all I need. I need to enter these three, and then I'm going to hit compute, and it will tell me the sample size. Okay, look at that. It basically solved this equation for you. It solved this equation for you. I entered Z margin of error as width, right? I entered width. I entered Z. Actually, I didn't even enter Z. All I did was I told it, this is the level of confidence I'm using. So it calculated Z by itself. And then I entered the target proportion, which was 0.52, and it solved this equation for you. It gave you N, and the N is 1689. Okay. No, Z is not always going to be 1.6449. Remember, Z is dependent on what your level of confidence is, right? If your level of confidence is something else, then you have to find the critical Z for that. Okay. So how did I find this? I said my level of confidence is 90%, right? So I did this using, yeah, StatCrunch will calculate it for you. Yes. So all you have to enter here is your confidence level. Okay. So it can be 95% confidence level. And then if you hit compute, you get a different result, right? I'm going to use 90% confidence level because that's what the question said. See right here? It says use 90% confidence. So I just entered 0.90 and it calculated Z behind the scenes. Okay. So it didn't show you, but it did calculate it. And then you use 0.04, and this is my answer. Okay. So that's your N. Huh. Is anyone else having any trouble with my session? I hope not, because it seems like Mel, it might be that you're using Wi-Fi, and if you're sort of away from the hub, sometimes you'll get that, you know. Yeah, that could be that. I mean, you may want to be closer to your hub if you're using Wi-Fi, because I'm using a hardline connection, so I'm using an Ethernet connection, so that should be fairly fast. Um, okay, did everyone follow this? Okay, now look what happens. I wanna do an exercise here. Look what happens here. If I increase my confidence level, okay, and say I want to go from 90%, I want to be more confident to 95%. What do you think will happen to my sample size? Do you think my sample size will go up or down? Everything else remains the same. I want to be more confident. Yeah, very good. It's gonna go up because I want to be more confident for the same margin of error. I should I should be required to have a larger sample to be more confident. If I hit compute, you'll see now I get 2399, 2400. I went from 1689 to 2400. Say I want to be 99% confident. Look at this. I go to 4144 sample size, right? The more confident you want to be, the larger the sample size is going to be. So let's go back to 90%. I get 1690. What happens if I want narrower width? So I want to be more precise. What do you think will happen to the sample size? I want to be more precise. I want to really, really be precise and find that the point estimate. What happens to the sample size? Well, let's think about it, okay? Let's think about it. If my width is small, I want to be more precise. Do you think I will need more units to be in my sample so I can be more precise? Okay, so some are saying less. Well, let's see. If I want to say I went from 4% width to 2% width, look at the sample size, it went up. That's because if I want to be more precise, I need to have more data. If I have less data, I will be less precise. If I have more data, I will be more precise. Okay, so that was a neat little exercise. Okay, now let's look at part B. Part B says essentially the same problem, but now they don't give you a previous estimate. They don't give you the target proportion, like this target proportion. They don't give you anything for this. So how do we solve this? Well, it says that she does not use any prior estimates. So it doesn't tell you what target proportion you should use. But I'll tell you what you should use. You should use 50% because 50% is the worst case scenario. Okay? 50% is the worst case scenario. So anytime they don't give you a target proportion, then you should always use 50%. 50% gives you the largest possible sample size. Okay? Yeah, I mean it's an estimate, right? If the previous estimate is not given, you use the worst case scenario, okay, which is 50%. So I'm going to go to 50%. I'm going to put this back to 4. The width was 4% for this problem. The confidence level was 90%. If I hit compute, I get 1691. Okay. Now here it's what it's doing is it's actually rounding. There's a rounding issue here, and yeah, so there's a little bit of a rounding issue, but I bet if you enter 1691 here, it will accept it. Okay. It does give you some room to make an error when you enter these answers. Okay, any questions on this? I think now that this should be simple. You know what StackCrunch is doing. You know it's calculating this equation. Okay, part B is just this 90, 50, and 0.04. Okay. All right. So let's look at the last problem. Maybe let me see. Yeah, let's do this tonight. It's a little bit of work, but let's do this. So what we have is we have two individuals who are trying to estimate proportion of adults who read at least 10 books last year. Okay, so the proportion of adults who read at least 10 books last year, or who read at least 10 books last year. To do so, she obtains a simple random sample of. So Katrina obtained a sample of 100 adults and constructed a 95% confidence interval. So I'm going to put this in a table form. My N and my level of confidence. What is my N? N is 100. And what is my level of confidence is 95%. Okay. Okay, now Matt is trying to do the same thing. He's also trying to estimate proportion of adults who read at least 10 books last year. But he obtains a sample size of 400 and constructs a 99% confidence interval. So 400 with 99% confidence interval. Okay. And this, you can't solve this equation without considering for we're still talking about proportions, right? So we're talking about p hat. And we know that p hat plus or minus the margin of error is your confidence interval. And you know that the margin of error equals z times p hat 1 minus p hat divided by n. Okay, we know all this. In this problem, you're going to be using this equation, the margin of error equation. And I'm going to find margin of error for both of these guys. Okay. So let me go to StatCrunch. So what I need to find is I'm not given p hat in this problem. So that's not given. Now the problem statement says, assuming both Katrina and Matthew obtain the same point estimate, the point estimate is the same, whose estimate will have smaller margin of error? Okay, who will have a smaller margin of error? Katrina or Matt? Okay, it's going to be hard to just say you're probably getting the right answer, but it's hard to just say it. You have to prove it. Okay, you have to make sure it's correct. It's not always going to be correct. Okay, at some sample size, the answer is going to be Katrina. Okay, so we have to prove it. Let's prove it. First, let's find Z. We know that N is given for both, right? We know N is given for Katrina and Matt. We have the level of confidence for Katrina and Matt. We don't have Z. So let's find the Z for both. Okay, so I'm going to put another column here called Z. Let's find it. So I'm going to use stat calculator normal and 95% for Katrina. So I'm going to go to between 95. I get 1.96. Okay. And the other one is 99%. So I'm going to put 99 here. I get 2.5758. Okay. Okay, let me just get rid of that. Now I can find my margin of error. So let's put these values in this equation for margin of error. So what is Z for Katrina is 1.96. Actually, let me just solve. If you don't mind, I'm going to solve it here and then put the value here. So for Katrina, I'm going to use K. The margin of error equals Z, which is 1.96, times P hat 1 minus P hat. That's not given to us. So I'm just going to type P hat 1 minus P hat divided by N, which is 100. Okay. This 100 has a square root. I can bring this out. And if I do, it becomes square root of 100, which is 10. So I can do this. I can do 1.96 divided by 10, and then square root of P hat 1 minus P hat. And if I solve it, I get 0.196 P hat 1 minus P hat. That's what I get. And that is my answer for Katrina. 0.196 P hat 1 minus P hat. Okay. Okay, I'm going to stop here. Tell me if you followed all this. I started from the margin of error equation. All I did was just plugged in these values, did some arithmetic here, and I got to this. Okay, good, excellent. I'm going to do the same for Matt. And I'm running out of room here, but let me try to. Okay. This can't be done in StatCrunch, no, because we're not going to get an answer. This is going to be sort of like it's going to be an expression. Okay, we're not trying to get one value out of it. All right, do the same thing for Matt. The whole thing. So what is the Z for Matt? The Z is 2.5758. Okay, times P hat 1 minus P hat divided by 400. I can bring the 400 out of the square root so that it becomes 2.5758 divided by square root of 400 is going to be 20. So I'm going to divide this by 20. P hat 1 minus P hat. And let me just write this here now. Essentially, this 2.5758 divided by 20 is going to be 0.129. And then P hat 1 minus P hat. Okay. Now notice this. The question said which one has less margin of error. So which one has less margin of error? Well, this whole thing is the same in both, right? This piece is the same in both. P hat 1 minus P hat. They're both the same. So let's just ignore this for now, right? They're both the same for Matt and Katrina because their P hats were the same. So the question really is which one is lower here? Is 0.196 lower or 0.129 lower? Well, 0.129 is lower. And that makes Matt's margin of error lower. Okay, so Matt actually has a lower margin of error. Okay, so this required a little bit of work, but we got to the answer. Now someone said, how did I calculate the Z's? So let me just show you one more time because this is very important that you get this correct. When you have a 95% say level of confidence, to get to the Z or the critical value, you use stat, calculator, normal, and you're going to use between, and then you type 0.95. And then it's going to give you the critical values here. And here we go. Okay, that's how I found my Z. It's 1.96. And then I just plugged it in this margin of error equation. I'm not given P hat, so I just leave it the way it is. And it cancels out because it's the same in both Katrina and Matt, because they get the same. The question said that they get the same P hat, so they can just cancel out. So really the question becomes, is this less than this or no? And the answer is 0.129 is less than 0.196. So Matt has a lower margin of error. So Matt's estimate will have smaller margin of error because the larger sample size more than compensates for higher level of confidence. Right? It's because Matt had to be more confident. So you would think that, that would be a problem, but you have a larger sample to work with. So that lowers your margin of error. Okay. Any questions? Isn't the P 10 divided by 100 over 400? I'm not sure if I follow. No, this is not P. This is N, right? The sample size. So now you're not going to divide the sample size, right? Or are you talking about this here? Well, so I think you're questioning this piece. Is that right? You're questioning this piece here? All right, so here, notice you have 1.96. This is what you have. 100 is for Katrina. So when you can bring the 100 because it's a constant. You can bring it outside of, you can bring it underneath 1.96. But if you do that, you have to take the square root of it. Square root of 100 is 10. So it becomes 1.96 divided by 10. And then p hat 1 minus p hat. And then in the next step, 1.96 divided by 10 is simply 0.196. P hat 1 minus p hat. And then similarly, you will do this for mat. So you're going to get, instead of this 100 here, you're going to put 400. And for 99%, you're going to put 2.5758. No, that's not p hat, right? Because this is the equation I'm working with. I'm not using p hat anywhere. The question said which one has lower margin of error. So I'm using the equation for margin of error here, right? This is the equation I'm using. I'm just plugging in values in this equation. Yeah, I'm sorry. This 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 is the equation. So Z, so in this case, take a look at this, Katrina. Z is 1.96, right? I found that 1.96. So I put 1.96 here. P hat and 1 minus P hat is not given, so I just leave it as is. N for Katrina is 100, so I use 100. And then I just solve this, right? Similarly, you're going to do this for Matt. And then you're going to solve it the same way, and you get these two margin of errors. And then it's just a matter of which one is lower. And you know 0.129 is lower than 0.196. No, it's not irrelevant. The question is, they're both trying to get this estimate, okay? If they use these parameters here, which one is going to have a lower margin of error? Lower margin of error is preferred, right? You want your estimate to have a lower margin of error. So anytime you create an estimate, your margin of error should be lower, as low as it can be, okay? Any questions? Otherwise, let's stop here, and then we will continue tomorrow from question number 8, which is the t distribution. Excellent.